In this video, we're going to go ahead and put together the GUI for our player. We're going to need a couple progress bars for our velocity and for our health, and that'll also introduce the fact that we need the concept of an game object actually having health, so we're going to create a mono behavior to encapsulate that information. However, before we start, I do want to address the small problem we have with the camera jerking a little bit. This actually comes from two problems with the code that was written. One that I slightly addressed earlier in the last video, but I didn't see the second problem. So let's go ahead and look at those. The biggest problem is that we are using the player transforms rotation, and that's what we're interpolating against. The second issue is that after playing around with it for a little bit, I'm not particularly happy with using interpolation in the first place. Now, there are a lot of places where this could be very much appropriate, but in this case, I kind of came up with a slightly more fluid camera feel for this particular game, considering that we are indeed in 3D space. So what I'm going to do is I am going to fix this so we are no longer interpolating our rotation, and I'm also going to make it so that we are directly transforming the rotation to look at a point ahead of the player so that we can see a little bit more of the player's ship model. So to remove the interpolation, I'm of course going to have to remove the rotation dampening property because we're no longer going to be using it. I'm also going to remove line 25, and I'm going to set this, instead of setting the rotation to something, I am going to simply say transform look at, and then I'm going to pass in a point that's actually ahead of the players. So player transform point, and then I'm going to pass in 0, 0, 50, and then I'm going to have to pass in player transform up. And player transform up is the normal that describes what the player considers to be up, so in his positive y-axis. So what I need to do is I need
Basically,
to match that.
we have to track the player because we're flipping around in 3D space.
Right. So we have to make sure that our up normal is the same as the player's up normal. Otherwise, the player would rotate on the screen independent of the camera, which isn't what we want.
There we go.
So yeah, so let's go ahead and move on into writing our GUI. I'm going to create a reusable progress bar component that I'm going to use for both our health bar and for our velocity bar that tells us how fast we're going relative to how fast we can be going. That's going to require me to create two more classes. The reason I'm doing two classes is I want to create a normal C# class called progress bar that basically hides all the there's not much complexity, but it hides the implementation details of a mono behavior called progress bar renderer that will actually perform the onGUI invocation. So what do I mean by that? Well, let's go ahead and stub out these two classes real fast. I'm going to create a class called progress bar, and progress bar is going to have a private read-only game object. And this game object will represent the renderer that will be an actual Unity game object. Now, because I haven't imported Unity Engine yet, I must click that button, which brings in a using Unity Engine there at the top. Next up, I'm going to have a private float value, which represents the current value that our progress bar is at. I'm going to have a public color, background color, for the background of our progress bar. And then I'm going to have a public color, foreground color, for the foreground of our progress bar. Next up, I'm going to have a public float max value with a get and a set, both public. Next up, I'm going to have a public vector to position for the position in screen space where this progress bar should render at, with a public vector to size, which is the size of the progress bar. Then I want a public bool is enabled because I want to be able to turn on and off my progress bar. To do that, the get will simply return gameObject.activeSelf. So is enabled will return true if the game object is active. The setter will simply say gameObject.setActiveValue. So we're basically delegating whether or not it's enabled to the private game object that we have. The final property I need is the value. Now the value of the progress bar is going to be a little bit more complicated. The getter is simply going to return our value public field, but the setter is going to clamp between the value passed in with 0 and max value. Because we never want to go below 0, and we never want to go above max value. So I'll simply say value equals mathf.clamp value 0 max value. And if you're not familiar with the way that C# properties work, when we're inside of a setter method, the value keyword is whatever the client of this code who invoked this property tried to set the property to. So now what I'm going to do is I'm going to create a constructor. Now what this constructor is going to do is he's simply going to instantiate my game object. So I'm going to say game object equals new game object. This game object is going to represent the actual physical rendering of the progress bar. So he's going to be responsible for actually displaying the progress bar to the screen, which means he'll have to be a mono behavior. So I'll create a new game object, then I'm going to say GameObject.addComponent progress bar renderer .init this. Now you'll notice that this doesn't work yet because we don't have the progress bar renderer mono behavior created yet. But I just wanted to fill out the entirety of progress bar before I wrote the renderer, because the progress bar is fairly straightforward. It's just a bunch of data. Again, the reason why I'm separating these out is I want to hide the mono behavior behind this progress bar class so that you have a very straightforward domain-specific interface into that behavior, as opposed to having access to everything in the mono behavior, which can lead you to doing things by mistake. However, because the game object is owned by the progress bar, we need some way to destroy it. So we simply write a public void destroy method that says object.destroy game object. This will be if we want to destroy the progress bar entirely, as opposed to hiding it, which we can do with this enabled. We invoke the destroy method, which gets rid of the progress bar renderer. Okay, so the next bit that we need to do with our progress bar is write the progress bar render. It'll be a simple mono behavior that renders out a progress bar onto the Unity's built-in GUI system. So I'm going to create a new class called progress bar renderer. And I'm going to have it inherit from mono behavior. Now remember, to have it inherit from mono behavior, it'll turn it into a mono behavior, but we'll have to be sure to bring in the using Unity engine up top. Now,
looking good.
Yep. The progress bar renderer is going to have two methods and one field. The field is going to reference back to the progress bar class so it knows what colors to use and what values to use. Then it's going to have a public void init method. Now we kind of already alluded towards the existence of this method, because now if we jump back into the progress bar class itself, we see that when we add the progress bar component to it, we initialize it by invoking the init method with a reference to itself. This is picked up by the init method that I've implemented here on the mono behavior of progress bar renderer, and it simply accepts a reference to a progress bar and it stores that reference away so that it can use it later. The final method that we need is public void onGUI. Now onGUI is a Unity method that will be invoked by the engine, and it'll be invoked by the engine because this class does indeed inherit from mono behavior. So this is why we need two separate classes. We can't have one class. Well, we could if it was a mono behavior, but it would make the interface to this class more complex. What we're effectively doing is we're hiding the complexity of a mono behavior behind this more generic class, and then the mono behavior itself is being hooked into Unity and is invoking the onGUI, or having the onGUI method invoked on top of it. Okay, so let's go ahead and render it out. To render it out, we'll need a couple things. We'll also be needing something that we haven't yet done. So let's go ahead and check this out. First thing, I'm going to say var old color equals GUI.color. Then at the end of the method, I'm going to say GUI.color equals old color. That's because I'm going to be changing the value of GUI.color, and I don't want that value to leak in to any other method or any other onGUI methods in my scene. So I store away the old GUI color, and then I reset it at the end of the method. That's because I'm going to be changing GUI.color to equal the colors of the rectangles that I'm trying to render. Now the first thing I'm trying to render is going to be the background, so I simply say GUI.color equals bar.backgroundColor. Then I'm going to say GUI.drawTexture, and I'm going to pass in a rectangle The rectangle is going to be located at bar position X, bar position Y, with the size of bar size X and bar size Y. So that's going to be the position and the size of the progress bar. But then we have to pass in a texture. Well, what I'm actually going to do is I'm going to jump into Photoshop in a second and create a square texture. Just a 1x1 square of a white texture, and that's it. And what's going to happen is by setting the GUI color to my background color, rendering out that square with the size of our progress bar will result in a rectangle being colored in that way.
Sounds fun.
So what I'm going to do is I'm going to say game resources dot square. Now game resources is not a class I've made yet, but once I do make it, all it'll have in it are public static fields that references resources that are loaded in by Unity, or by our application, but through Unity. So let's finish the rest of my implementation of my progress bar, and then we'll go ahead and put together our square in Photoshop, and we'll write our game resources class. The next thing I need to do is I need to draw the foreground. So I simply set the GUI color to my foreground color, and then I do another draw texture, but this draw texture is going to be a little bit more complex. I'm going to pass in a new rectangle. The rectangle is going to be positioned at bar position X, bar position Y. However, its width is going to be calculated depending on how far the bar is supposed to be filled. We know how far the bar is supposed to be.
Farble barble?
Farble barble, yeah, pretty much. We know farble barble because of the value of the progress bar object and the size of the progress bar and the max value of the progress bar. It's this very simple ratio. Remember, cross multiply and divide. So we simply have to do bar.value multiplied by bar.size.x divided by bar.maxValue. That will fill in this foreground to be the percentage width that it needs to be to represent the current bar's value. Next up, we have to pass in a height. Now the height is going to be really simple because it's simply bar size y. Now, as far as the actual texture we're rendering, it's going to be game resources dot square, which we haven't implemented yet, but we will here in a moment. So this is all our progress bar render needs to be. We're simply making it so that we can reuse this logic over and over again so we don't have to write a whole lot of code every time we need a progress bar. And again, we have our nice little progress bar facade, which this is just a class that represents a facade over more complex implementation details that allows us to very simply position and hook up a progress bar in the way that we want. So let's go ahead and create our game resources. Before I do that, I want to go ahead and create the texture that we're going to be using. I'll place it inside of Unity, and then I'll create a class that will hold a reference to that texture that I can reuse throughout the rest of my project. So I'm going to open up Photoshop. I'm going to hit File, New. I'm going to create 1x1, and I'm going to leave it white. That's literally it. It is a square.
Doesn't get much simpler than that.
Yep. So I'm going to go ahead and save it. Come on, let me save. Or save as, whatever. And I'm going to go ahead and navigate into my project. Find the project. Okay. So here's our project. And then here's our Unity project. Here's our assets folder within Unity. Then I'm going to open up the textures folder. And I'm going to create a new folder called resources. And I'll explain the significance of that in a moment. And then I'm going to call this square. Now I'm going to leave it as a PSD. That's because Unity understands PSDs and will compress them appropriately when we build out our players, which is really cool because it allows us to keep our PSDs with all our layers and blending effects and all that fun stuff. And then when it comes time to build the player, Unity will rasterize them and compress them for us.
That's very nice.
Yes. So now that we've done that, if we jump back into Unity, we'll see some errors because we don't have the game resources class written yet. But we'll see under textures, resources, we'll see our square. Now, I'm going to go ahead and just set the max size to 32, not that it probably matters. Keep the wrap mode to repeat, that's fine, and then just hit apply. Now, it's important that this is under the resources folder because what I'm about to do is I'm going to write a class that loads this asset up dynamically when the game starts. That's because I'm not actually clicking and dragging and placing the square onto a game object or a mono behavior. I'm loading it dynamically from within code. Whenever you do that, you always must place those assets inside of a folder called resources. Otherwise, you won't be able to load them dynamically from code. It's also important to note that when you build out a player, every asset inside of any folder called resources will be included. That's actually different from the behavior of Unity typically, because typically Unity will know what assets are being used and what assets are not being used, and it'll omit the ones that aren't being used by a particular build. But when you place something in resources, it'll be along for the ride all the time. However, that doesn't matter because we do need this all the time, so we're placing it in resources and we're going to load it dynamically through code. Now, loading it dynamically through code is a lot less scary than it sounds. All I'm going to do, like I've been saying over and over again, is I'm going to create a class called Game Resources. And Game Resources is simply going to load up our resources. So I'm going to go into code. I'm going to create a new class called Game Resources. I'm going to make it static. It's not going to make a difference either way, but it makes the intent of the class more clear. And then I'm going to say public static texture. Now, because I'm importing texture, I need to bring in using Unity Engine up here at the top. And then I'm going to say square equals cast to texture resources.load square. So now that I've done that, we now have a square texture object or resource that's been loaded into our game that we can reference from anywhere inside of our code. So if I go back to Progress Bar Renderer, you see that this is no longer an error because we have indeed written the Game Resources class. So now if I jump back into Unity, our errors should go away, and although if we hit run though, we won't see anything different because we haven't actually used our progress bar anywhere. Let's go ahead and fix that. What I'm going to do is I'm going to create another sort of subcomponent for our player that contains all of his GUI logic. So what do I mean by that? Well, you know how I have the player camera and player controller that are kind of being used by player? I'm going to do that again for the player GUI. So I'm going to say, I'm going to create a new class called player GUI. Player GUI is going to have a constructor. The constructor is going to take in a player controller and a player. Then I'm going to assign my two new private fields that I just created to these two things that were passed into the constructor. However, I'm also going to need my progress bars. So let's go ahead and work on our velocity progress bar first, and then we'll do our health progress bar. So I'm going to say private read-only progress bar, velocity, progress bar. Now, I'm going to, inside of my constructor of player GUI, I'm going to instantiate it. And I'm going to use object initialization syntax to set all of its properties. So let's think about the size. How big do we want this guy to be? Well, let's go ahead and give it, how about 25010? Note, by instantiating a new vector 2, I got a Unity engine at the top. So that's his size. What about his position? His position is going to be 10 in x, then screen.height minus 10 minus 10. Okay, so why am I doing minus 10 minus 10 and not minus 20? Well, it's a very common thing that, or common practice that I use with most math involved in game development, especially when using Unity or any game engine really, is I like the calculations to be a little bit more explicit. I'm subtracting 10 from screen.height because that is the height of my progress bar. Then I'm subtracting 10 again from that because I want 10 pixels the velocity progress bar to be 10 pixels above where the height is. Does that make sense?
Indeed it does.
All right. So the next thing I'm going to do is I'm going to set the background color. Set the background color to a color I already have in mind, which is simply going to be 199.231.255. And then I'm going to set the foreground color to a new color of 0.145.255. Nice little bluish colors I came up with earlier. And I'm going to go ahead and leave it like that. Now, there's one more important thing that I want to have in my player GUI, and that is going to be the size of his current cursor, because not only am I setting up my velocity progress bar and my health progress bar, but I'm also going to be displaying the cursor, the targeting crosshairs for the player. That's going to follow along where the mouse is. That's the reason why I brought the player controller reference into my player GUI, so I can get the current mouse position from the controller. So to do that, I'm going to say public float current cursor size. Now, I'm not going to actually be changing the current cursor size at all inside or in this particular series. In a later series, we will be changing the current cursor size to get a little larger when you're targeting an enemy. But for now, I'm placing it into a variable so that I don't have to hard code the current cursor size in every time I need that calculation. I'm going to set the current cursor size to 20 pixels. So it's going to be 20 by 20 pixels. Next up, I'm going to need two methods. I'm going to need a public void update and a public void on GUI. Remember, these aren't methods that are going to be magically invoked by Unity, because this is not a mono behavior. Because it's not a mono behavior, update non-GUI won't be invoked directly by Unity. Instead, we're going to be invoking that from the player mono behavior. Now, the responsibility of the update method is going to simply be to tell our progress bars to update their current values. So that's very easy to do. I'm going to say velocity progress bar dot max value equals controller max variable velocity plus controller afterburner modifier plus controller minimum velocity. So this is the maximum velocity that a player can ever be going. So that's why I'm saying the velocity progress bar's max value to this equation. Next up, I'm going to set velocity progress bar dot value to equal controller dot current velocity. Sound good?
That sounds absolutely awesome, sir.
Sweet. So before we go ahead into getting our current cursor being printed out by this onGUI method invocation, I do want to go ahead and hook up my player GUI component to my player and see if my velocity progress bar does indeed work. So going back into my player, I have to add another private field which has a reference to player GUI. Player GUI will be instantiated inside of my awake function, and it'll pass in a reference to the controller and a reference to the player. Now it's important, because the player GUI's constructor relies on the existence of a controller, I must instantiate the controller before I instantiate the GUI. Also, this is going to really bug me. I have a bit of a lopsided convention here, where my player camera I passed in the player as the first parameter, but on my player GUI I passed in the second parameter. That's going to really bug me.
You should fix that.
Yeah, it doesn't make any difference at all. I'm simply going to swap these two arguments, and then I'm going to go back to player GUI and swap these two parameters. It makes literally no difference whatsoever, other than to make my OCD feel a little bit better.
Yeah, to make you not crazy, which is important.
Yeah. So now we have a nice level of symmetry between these two. Anyway, so now that we have that done, we've effectively hooked our player GUI almost all the way into player. But we have to update it. Now I'm going to update it after the controller. So I'm going to say player GUI.update. I'm updating it before the camera for no particular reason other than I still like the idea of the camera being the last thing that happens. It literally doesn't matter. but it does matter that I update it after the controller because the player GUI will pick up on the values that the controller set for this frame. Next up, I'm going to do an onGUI. Now remember, the onGUI is going to be invoked by Unity because player does indeed inherit from onBehavior. So the onGUI is simply going to invoke player GUI.onGUI. Now that I've done that, I'm going to jump back into Unity and hit play and see if my velocity is working. And look at that.
Sure is.
So now I can see, like, when I hold down tab, you see my afterburner modifier comes into effect. If I hit S, I slow down. If I hit W, I move forward. And I can go super fast, or I can go, like, not at all forward, which is cool.
Thing of beauty, man. Looks awesome.
Sweet. So now let's go ahead and get my target crosshairs working. So like I said before, the player controller itself owns the information as to where this is a really convoluted sentence, so I will start over. The player controller yeah, indeed. That's what happens when you talk for so long. The player controller is the one who knows where the mouse position is. It needs to know that because it can support relative or absolute positioning for the mouse. So with that information, I can go into the player GUI class, and on his onGUI method, I can actually draw the target player reticule to wherever my controller thinks the mouse position is. Okay, so to do that, I actually need to create a targeting reticule. So let's go ahead and jump into Photoshop and put one together real fast. Let's make this 64 by 64 pixels. And again, you can use whatever program you want for this, and this will be included in the assets for this video series. But I just want to go ahead and just take a step back and have some fun. So let's go ahead and start off with a very simple vector sphere, if I can find that, my ellipse tool. And I'm going to place my ellipse like that, and like that, with the width and height of 64. That's perfect. So there's my ellipse. I'm then going to go into its blending properties. I'm going to take its fill opacity down to nothing, and I'm going to give it a stroke. I'm going to make it appear in this. Do I want to do inside?
You probably want inside, don't you?
Yeah, I'm actually.
Since you pushed it to the edge.
I'm going to make it a little. I'll stick on outside, and I'll change it a second. Everything is going to be white, so I'm going to make it white, and I'm going to hit OK. And now I'm going to zoom in a little bit. I want to delete my layer 0 so that I can see my white. I'm going to hold down Shift and Alt and make this a little bit smaller. How about 56 by 56? Hit Enter to confirm the free transform. Actually, I want to make it a little bit smaller than that, and you'll see why in a second. Because now what I'm going to do is I'm going to create a new layer. I'm going to come up here to the top, and I'm going to create a little guy like so. And then let's fill him in with white. Then I'm going to control click on both layer 1 and ellipse 1. I'm going to go into my move tool, and I'm going to center them vertically. They seem to, or horizontally, they seem to already be centered horizontally, which is exactly what I want. So now what I'm going to do is I'm going to take this, and I swear there's a way in Photoshop to make a path that I can rotate this around, but I'm just going to go the super lazy way and just do it like this. By the way, I'm holding down Shift to constrain my axis and Alt to duplicate. Then I'm going to control click on this, make him flush with the edge. Then I'm going to hit Shift and Control, select both of these, duplicate them, move them back on themselves, and then rotate them. And nudge them to the left because I think I'm off by a pixel. Now is that centered?
Go a pixel down.
Actually, I can just control click on the ellipse one and hit this button right here. Yep, distribute vertical centers says that this is correct.
There we go.
All right, so that's my player target reticle. So let's go ahead and hit Control S, and I'm going to save this into my resources folder under my textures. And I'm going to name it something, if I can remember how to spell what I want to name it to. It's a funny word anyway, reticule. I'm going to call it player, actually I'm just going to call it target, R-E-T-I-C-L-E. Save it. I'm going to come back into Unity. I'm going to select target reticule. I'm going to say max size is 64. And I'm going to keep everything else the same, except I'm going to say alpha is transparency. And then I'm going to hit apply. Okay.
Very cool.
So that makes me able to have a resource that I can load up in the game. To actually load it up in the game, I have to go into my game resources, and I need to create a public static texture target reticule equals texture resources.load target reticule. So now I can reference that asset from within my code. Sound good?
That sounds very good.
Awesome. So let's go ahead and put it to use by jumping back into the player GUI. And on his onGUI method, I'm simply going to say GUI draw texture, passing in a new rect. Now, we're going to have to pass in the X, the Y, the width, and the height. So the X is going to be controller.mousePosition.x minus current cursor size divided by 2. We need to subtract half the current cursor size to get it to be centered on that point, as opposed to just being at the top left at that point. For its top, it's going to be a little bit more complex because we actually have to invert the screen position. So I simply say screen.height minus controller.mousePosition.y minus current cursor size divided by 2. And then, not surprisingly, for its width, we're going to pass in current cursor size, and for its height, we're going to pass in current cursor size. And I'm missing a comma right there. Finally, the last argument we're going to supply to GUI.drawTexture is going to be game resources. So now we simply pass in game resources dot target reticule. So by doing that, if I jump back into Unity and hit play, we'll see that we do indeed have a target reticule placed on our mouse cursor, and it is centered properly. Now, it looks a little bit better if you were to hide the mouse. So I can go back into my, just give you guys an idea of what it would look like if I went into my player controller and set his use relative movement to true. And if I come back here, it now makes a little bit more sense. And that makes a little bit more sense because that's all we see. That is now our mouse cursor. Look good?
Looks very awesome.
Alrighty. So next up, let's go ahead and implement our health real fast. Now, our health is going to be implemented on the player, but it's going to delegate to a new mono behavior that I'm going to create. It's going to be a very simple, kind of, I guess you could say, utility mono behavior that has the concept of health, and that will be able to be tied in to our different on-trigger inter-implementations for things like projectiles and asteroids and all that fun stuff. So I'm going to go up here into code, and I'm going to create a new class called Destroyable. Now, Destroyable will be a mono behavior, and it's going to have, note that Unity Engine did come in at the top. It's going to have a public float max health and a public float health. Now, currently, that's all it's going to have. It's just going to be a container for max health and health. It's not going to actually have any logic in it quite yet. It will in the future once we start talking about collisions. But that's enough for us to work with right now, because if I jump back into my player mono behavior, I can add a public reference to a destroyable. Then what I can do is I can add a public property, so public float health, which simply says get return destroyable health, and then a public float max health, which get return destroyable max health. So those are two just nice little convenience properties that we can use to reach into our player and grab the information from our destroyable. So our health and our max health will be used by our player GUI to update a progress bar. Let's go ahead and finish our code first, and then I'll create the destroyable component on our player and wire it all up. Jumping back into player GUI, what we need to do now is create another progress bar. So I'm simply going to say at the top, private read-only progress bar health progress bar. Now, health progress bar I'm going to instantiate in the constructor in much the same way as I did the velocity progress bar, with different parameters. Now the size, I'm simply going to set to velocity progress bar dot size. Whatever my velocity progress bar size is, I want my health progress bar to be. The position is going to be a new vector 2, passing in the velocity progress bar dot position dot x. We want them to be in the same x position. And then the velocity progress bar dot position dot y minus velocity progress bar dot size dot y minus 10. This way, if we update our velocity progress bar in any way, our health progress bar calculations will still be relevant. Finally, I need to set its background color and its foreground color, and I already have some colors picked out for this one. The background color is going to be 199, 231, 255, and our foreground color is going to be a new color of 0145, 255. Give us a nice red color. Or blue color.
Very nice. I like the relative position thing too. I wouldn't have thought of that.
It just makes the code just a little bit easier to change in the future. Okay, so next up, our update. Our update is going to work the same way as our velocity progress bar works. We're simply going to say health progress bar dot max value equals player dot max health, and then health progress bar dot value equals player dot health. Now this way, the player GUI class is only responsible for showing information about the current player. That's a very important thing to note about the way I've separated this code out. The player himself owns his data, and the player GUI just displays that data. That's why we're simply passing data along from our player to our progress bars. Now the final thing to make this code work is I need to actually attach the destroyable mono behavior to my player, and I need to set it up with a health and a max health. So jumping back into Unity, I can click on my player game object, hit add component, and type in destroyable, and hit enter. Let's give it a max health of 100 and a current health of 100. Then we can click and drag the destroyable script right onto this destroyable field that is created on our player. By doing this, if I hit play, we now have let me turn off that relative position, or the absolute, or the relative positioning. Yeah, I think that. There we go. We have a problem with the color. However, I think I got the colors wrong. How'd you let me get the colors wrong, Steve?
Because I don't know them by number.
Unacceptable.
I know.
I actually completely didn't do the right colors for the health at all. Let's show you guys a really cool program that I use quite frequently called Color Schemer Studio. Highly recommend it. I'm going to pick this color as my background. So I'm going to grab these RGB values. So that is 255, 199, 208. Then for the foreground color, I'm simply going to saturate it some more. Maybe make it less purple and take brightness. I think that looks good. And that's 1946262. Coming back into Unity, we now see nothing. There we go. Oh, you know what I did? uh,
What what did you do, Nelson?
I totally I dropped the ball, guys. Um, you'll always want to make sure that when dealing with Unity colors, you are dealing with values between 0 and 1, which means that if you want to convert from RGB, where RGB goes from 0 to 255, you simply have to divide that number by 255, and then you get the proper representation inside of Unity.
Ah.
So I'm simply doing that. I am also adding the F suffix to at least
I was about to ask about that. Is that because when it divides, you'll end up with a decimal point?
right when it divides. If it's dividing two integer literals, it will just it depends on the context. I like to be explicit about it though, because you don't want to do integer division. You want to do floating point division because if you do integer division, you lose the decimal point. So that's why I'm adding an F to each one of the, or at least one of the components of each one of these operations. That being said, this calculation is done by the compiler. There's no performance penalty by me not pre-computing this, because the compiler will do that for me.
Gotcha.
Coming back into Unity, there we go. That looks a lot better, doesn't it?
Yes, it does.
I don't know why I noticed, like, I didn't notice before that, like, the color was way, way too saturated. But yeah, the explanation again is that the RGB values go between 0 and 1, not between 0 and 255. But simple math allows us to correct that mistake.
I just thought you wanted the two bars to be the same color, so I didn't think anything of
No,
it.
that'd be silly. Health needs to be red.
Well, that's what I thought, but hey, your game.
Okay, so I think that pretty much wraps up the player GUI. And pretty much most of the player, well, most of the player, actually. Next up, we have weapons. So let's go ahead and commit our code. Go ahead and select all, and I'm going to stage all these guys by adding them to the index, and then I'm going to commit. And I'm going to say player GUI, or hit commit. And we are done.
Awesome. Let's get on to those weapons.
Alrighty.